Alrighty, so in our previous videos for our mini unit, we talked a little bit about how arithmetic sequences and series. So arithmetic sequences is a sequence of numbers where we have a common difference to add from one term to the next. So in this video, we will talk about geometric sequences and how they're similar or different than arithmetic sequences. So the first step to doing this is, so it's to circle the following sequences that are not arithmetic. So I'm looking for things that are not arithmetic, meaning that I don't add from one term to the next. But before we do that, if you would like to go ahead and print out this notes sheet, you are welcome to. It is all linked for you in Canvas. So if I take a look here, going from 2 to 4 to 6 to 8, it looks like my common difference, I'm adding 2 each time. So that is an arithmetic sequence. Going from 4 to 8 to 16, this is not an arithmetic sequence, so I am going to go ahead and circle it. Going from negative 87 to negative 81 to negative 27 to negative 9 to negative 3. It looks like I am certainly not adding or subtracting by the same number there. I do not have a common difference, so I'm going to go ahead and circle this value right here. If I were to turn these into common denominators, I would have 2 twelfths. That would give me 1/6. I would have 3 twelfths here and 4 twelfths here. So it looks like I'm just adding 1/12 each time, so that is an arithmetic sequence. This looks like it would be an arithmetic sequence. I'm adding 4, so my common difference is 4. So you can kind of see what's happening here. The sequences that are not arithmetic we're going to go ahead and give them the name of geometric sequences. So from negative 5 to negative 10 to negative 15, so that is an arithmetic sequence. So I'm going to cross this one out. I'm going to cross this one out, cross this one out. We'll cross this guy out right here. 32, 16, I'm going to go back and circle that one. That is not an arithmetic sequence. And here, this is also not an arithmetic sequence. So these are what we call geometric sequences. So the sequence circled above are geometric. Geometric sequences have common ratios instead of common difference. So we have common ratios here. So arithmetic sequences, we have common differences. We add or subtract to get from one term to the next. Geometric sequences, we multiply by a common ratio to get from one term to the next. So my geometric sequences are multiplication. So I have a common ratio. So here I can see 2 times 2 is 4. 4 times 2 is 8. So my common ratio here is 2. 32 to 16, 16 to 8, and 8 to 4. So we have to be really careful when we talk about geometric sequences and the common ratio. So I always want to express my common ratio in terms of multiplication. So instead of saying that my R value here is to divide by 2 each time, that is actually not correct. I'm actually multiplying by 1/2 each time. And the same thing is happening over here. My R value is 1/2. Here, it looks like I'm dividing by 3 each time, so my R value, I'm actually multiplying by 1/3, not 1/2. So if you'd like to go ahead and think about how arithmetic and geometric sequences are similar and different, I encourage you to take out a sheet of scrap paper and go ahead and fill in this Venn diagram, right? So arithmetic sequences, we add and subtract. Geometric sequences, we multiply. They're both a list of numbers separated by commas. We can add the list for both of them, which we'll talk about geometric sums in a little bit. There's a lot of things that they have in common, a lot of things that make them different. Here we have common differences and common ratios, but they each have something special about them that allows you to notice a pattern and get from one term to the next. So here it says, determine whether each sequence of numbers is arithmetic, geometric, or neither, and then find the next 3 terms. So we'll just go through here and we'll find the common ratio if there's one that exists for each of these, and I'll show you how to find that common ratio. So if I want to figure out the number that I multiply by to get from 256 to 128, and is that the same number that I would multiply by to get from 128 to 64? So is 128 divided by 256, is that the same as 64 divided by 128? And it actually is. 128 over 56 is 1/2, and this is also 1/2. So really what I'm doing here is I'm multiplying by 0.5 to get from one term to the next. So here I would have 16. 16 times 1/2 is 8, and 8 times 1/2 is 4. So taking a look at the next one, I'm just going to erase this to give me a little more space. So is the ratio of 9 and 4 the same as the ratio of 9 and 12? So is 9 divided by 4 the same as 12 divided by 9? So 9 divided by 4, that's going to give me about 2.25, and 12 divided by 9, that is not quite close to 2.25. So this is not a geometric sequence. So there's no common ratio here, whereas here we get a common ratio of 1/2. There's no common ratio for B. To go from 4 to 9, I can add 5. To go from 9 to 12, I add 3. So this is actually neither. It's not arithmetic and it's not geometric. So let's move on to our next piece here. Is the ratio of 3 divided by 1 the same as 9 divided by 3? And it is. So my common ratio here is 3. So multiplying by 3 each time, 81, and so on and so forth. So 27 times 3. Here is the ratio of -15 over -20. Is that the same as -10 divided by -15? And it is not. This is actually an arithmetic sequence where my common difference is 5. I'm adding 5 each time. So 0, 5, and 10 would be my next 3 values. 2 to 8 to 14 to 22. So is the ratio of 8 over 2 the same as 14 over 8? And we know that it's not, so this has no common ratio. This is not geometric. To go from 1 to -4 to 16 to 64, so I can see that my negative is alternating after every other value, which makes me think that this might have something to do with multiplication, and it does. If I were to go ahead and investigate the common ratio here, I could say, is -4 over 1 the same as 16 over -4? And it actually is. My common ratio here is -4. But when we look at this sequence of values, we have positive, negative, positive, negative. When we talk about these geometric sequences, as we multiply to get from one term to the next, it makes us think of exponential functions. And so talking about geometric sequences, we can say that the common ratio here is -4. But if we were to sort of move that in the direction of talking about exponential functions, we would actually say that this is neither, because of the way that my function would hop sort of up and down for those outputs of positive, negative, positive, negative. And we'll talk a little bit more about that as we move forward with our exponential and logarithmic functions and equations. So our goal for today is to find an equation to come up with the nth term of any geometric sequence. So if I were to take one of my geometric sequences, so let's examine C. So 1, 3, 9, and 27. So let's go ahead and organize it like we have before. So I have my term number and my actual term. So I have my first term, my second term, my third term, fourth, fifth, sixth, so on and so forth. So I have 1, 3, 9, 27, 81, and so on and so forth. So if I were to take a look here, it looks like my first term is 1, my second term is 3, my third term is 9. And since I'm multiplying to get from one term to the next, I know that I am talking about an exponential function or an exponential equation here. So if I look, it looks like my first term is 1 times 3 to the 0 power, which is 1 times 1, which is 1. My second term is 1 times 3. My third term is 1 times 3 times 3. My fourth term is 1 times 3 times 3 times 3. So if I think about how I could represent this in terms of exponents, it looks like what I can actually do is say I have my first term, which is 1, times 3 to the n minus 1. So here's 3 to the first power. This is 1 times 3 squared. This is 1 times 3 cubed. And if you look, I have 4 and 3. So if I subtract 1 from both of those, it looks like I can say that a of n for this particular geometric sequence is 1 times 3 to the n minus 1. And for any geometric sequence, I can say a of n is my first term times my common ratio raised to the n minus 1. So this is our equation to find any term of any geometric sequence.